This is a video for OCR Pure Core Mathematics, Hyperbolic Functions 1, Introduction, 1.1, Definitions and Graphs of Hyperbolic Functions. Have a look at this picture. The curve formed by the chain, as it hangs under its own weight, looks like it might be a parabola, but in fact it's not. It's a particular type of curve which we call a catenary curve. The simplest form of this is y is equal to a half e to the x plus e to the minus x. This is actually one of the hyperbolic functions, and as a family of functions they're similar to trig functions in the way they behave sometimes. The next slide will show you that this one is cosh of x, the hyperbolic cosine. Okay, there's the definition of cosh x then. Let's have a look at the graphs of these two bits. There's e to the x, there's e to the minus x, and cosh x is, add them together and divide by 2, it's effectively the average of these two curves. So here it's going to be 1. As we get x increasing, e to the x is going to take over from e to the minus x, and so it'll disappear off the graph somewhere up here. And similarly, when x is negative, it's going to disappear off somewhere here, with e to the minus x being the more powerful. And there, in fact, is cosh x. So what happens as x tends to infinity? Cosh x tends to infinity as well. And what happens as x tends to minus infinity? Cosh x again tends to infinity. Okay, here's the definition for the hyperbolic sine. Sinh x is how we pronounce it. And this is e to the x minus e to the minus x over 2. Well, here's e to the x and e to the minus x, and we want to look at the difference between them. So when they're both equal to 1, it'll go through 0. Here, the difference between them, well, e to the x is large and positive, e to the minus x is pretty small, so it's going to disappear off the graph this way. And at the other end, e to the minus x is positive, but I'm taking it away, so I'm going to get a negative big number, and e to the x is insignificant, so it's going to fly off down here. And there is the graph of y equals sinh x. What happens as x tends to infinity then? Sinh x tends to infinity, and as x tends to minus infinity, sinh x tends to minus infinity. Okay, so here are the graph of my two functions. What can we say about them? Well, the first thing to notice is that cosh x is an even function. It's symmetrical about the y-axis. The value of cosh x for a negative value of x is the same as for the same positive value of x. And the other thing to notice is that cosh x is always greater than or equal to 1. Sinh x is an odd function. We can rotate sinh x by 180 degrees and we'll get the same form. It has a rotational symmetry. Sinh x for a negative value of x is minus the same positive value of x. So sinh of minus 2 is minus sinh of 2. Sinh can take any value between plus and minus infinity. This is looking at some algebra to look at whether they are odd or even, and so we get that cosh x, cosh minus x is equal to cosh x, so it's even, and sinh minus x is equal to minus sinh x, so that's odd. And we'll use the definitions of these things in terms of e to the x's at a number of points when we're working with hyperbolic functions. What happens if we add these functions? Well, if we look at sinh x is e to the x minus e to the minus x over 2. plus e to the x plus e to the minus x over 2. And I think you can see that these bits are going to cancel out, and we're going to get left with 2e to the x over 2. In other words, we're going to get just e to the x. What about dividing them? Well, I want to look at what happens if I've got sinh x, that's the amber line, divided by cosh x. Well, the first thing to note is that here at 0, I'm going to get 0 over 1, which is 0. For larger values of x, you can see that these two are very close together, with sinh just being a little bit smaller than cosh. So it's going to tend towards an asymptote here at y equals 1. And for negative x, I've got very large and negative values for sinh and large and positive values for cosh, and again it tends to an asymptote out here at y equals minus 1. And there's the graph of tanh x. So here is that with some of the algebra put in. There I've got sinh x over cosh x, and with a little bit of rearrangement, dividing top and bottom effectively by e to the x, I get that tanh x is 1 minus e to the minus 2x over 1 plus e to the minus 2x. What happens as x tends to infinity? Well, as x tends to infinity, this bit tends to 0. E to the minus 2x tends to 0. And what happens here is then, this is just 1 over 1, so tanh x tends to 1. As x tends to minus infinity, e to the minus 2x also tends to infinity. So this becomes effectively two things where I've got a large and negative value on the top and a similar large and positive value on the bottom. These 1's become insignificant in comparison to the e to the minus 2x term, and so I get a negative over a positive, and they're roughly the same size. It tends to minus 1. So let's look at the domain and range for each of these functions then. The domain for cosh x, well, it can be any value at all, so we say that x is a real number, and indeed for sinh x we get the same thing. X can be any real value, and similarly for tanh, x can be any real number. The range, well, cosh x is greater than or equal to 1, and we saw that earlier on in this video. Sinh x can take any value at all, so sinh x can be any real number. And as we've seen earlier on, tanh x lies between 1 and minus 1. The next video in this sequence is 1.2, Solving Simple Equations.